Welcome to qnawire.
So this problem gives us a lot of information and asks us to answer several questions. So letter A says, did the company reduce the amount of lead in its product between March and May? And the answer is yes. The PB levels went from 3.5 to 2.8 to 2.4, so it was reduced. B asks which metal was not reduced, and that would be zinc, because zinc went from 2.7 to 3.2 to 3.7. So zinc increased, it was not reduced. C says each month's sample represents a different manufacturing process. And which process would you recommend the manufacturer choose to continue to use over the next year while additional processes are tested? And I would recommend maize because the overall amount of metals are the lowest in May. Question D asks, what is the total amount of the 5 metals for the April sample? So we just add all of them up. 3.2 plus 2.8 plus 0.092 plus 1.6 plus 29.2. And that gives us 36.892 milligrams per kilogram. And that's our final answer for D. Letter E asks, what is the total mass in milligrams of the 5 metals for the April sample found in the 1.000 decimeters squared by 0.0500 centimeter sample? And so first we need to find the volume. So we'll convert both of these into meters. 1.000 decimeters squared is 0.1 meters squared. And 0.05 centimeters square or centimeters is 0.0005 meters. And so this gives us a volume of 5.000 times 10 to the negative 6th meters cubed. So now we can take our answer from the previous D, 36.892 milligrams per kilogram, and find just milligrams. So we're given an average density of 800 kilograms per meter cubed. And then we can multiply by our volume. And then meters cubed cancel, kilograms cancel, and we get our answer in milligrams, which is 0.15 milligrams. Now letter F gives us the mass, or gives us the isotopes and abundances for lead, and asks us to find the mass of lead 208 in the sample. And so first we can find the total mass of lead. 2.8 milligrams per kilogram is our sample. We multiply by that same density and then that same volume, and we get that we have 0.0112 milligrams of lead. And now we want to find lead 208, which is 52.4% abundance. So we multiply by 0.0524, and we get that we have 0.00587 milligrams of lead 208. And that's our final answer for letter F. Now letter G wants us to sketch the mass spectrum of lead. And so we have 4 different isotopes: 204, 206, 207, and 208. And we're given the percent abundances: 1.40%, 24.10%, 22.10%, and 52.40%. Now we want to divide them all by the largest, 52.4, to get our intensities for our mass spectrum sketch. And so that gives us intensities of 2.67%, 45.99%, 42.18%, and 100% for lead 208. Now we can sketch our mass spectrum. On the y-axis, we have intensity in percent. And on the x-axis, we have mass in AMU. And so on this x-axis, we have our isotopes 204, 206, 207, and 208. And now we just fill in the intensities. So we have 100 up here and 50 here. 204 is a really small peak. 206 is just under 50. 207 is just under 206. And 208 is 100%. So we have 100% here. Here we have 42.18%. Here we have 45.99%. And here we have 2.67%. So this is our sketch for the mass spectrum of lead.